This is the video of the homework for Unit 2B.1. We're working on the properties of exponents. So here we have a power of a power. And to handle that one, there's two different ways to think about it. This is 2 squared times 2 squared times 2 squared. It's 2 squared cubed, which of course would be 6. The shortcut is to multiply the two together. So 2 to the 6th power. Here we have the exponents of 3 and 1 with a common base of -3 to the 4th power. Now if you want to call that 81, that's fine, but I really want to see the exponent work. You don't have to write these out 3 different times, but I need to see the 2 to the 6th before we get to the other values. 2 to the 6th, you can count that out with your fingers. 2, 4, 8, 16, 32, 64. Okay, just double yourself all the way through. You don't have to memorize things. That would be 64. I'm completely fine with you leaving it with exponents unless there are factors that you, or products, that you actually know. Here, when we're subtracting, as long as you're subtracting the same base, we would subtract exponents. That gives us 5 to the -3. If it's a negative in the exponent, then we're going to put it into the denominator. And that's fine to be written as 1 over 125. Do not write the decimal. No decimal answers. Here, we would typically distribute the negative, or let's say the whole exponent, to both of these. So we get 2 to the -3, 5 to the -3. The negative exponents change the side of the fraction. So this becomes 5 to the 3rd power and 2 to the 3rd power. Here we have 3 squared. Because the denominator has a negative exponent, it's going to go to the top. So that's a total of, when your bases are the same, you add exponents, that's a total of 3 to the 3rd power. You can call that 27, but you need to have the exponent work before you do that. You need 3 to the 3rd. Here we have the same base all the way through. So it's 3 plus 0 of them minus 5 of them. So that seems like -2. So if it's a negative exponent, that's going to go into the denominator. And we can call that 1 over 36 if we wish. So if the bases are all the same, you add exponents. If you're dividing the same base, then you subtract exponents. So it's -2 minus 6. That gives you a -8. Well, we don't leave answers with a negative exponent. Do not have any negative exponents. So the negative exponent, if it's not in a fraction already, then it goes to the denominator. Here, since we are squaring a monomial, this is not a binomial, this is a monomial, so we are going to distribute in to get 2 to the 4th. When you distribute, you multiply exponents. Y to the 6th. And you can leave it in that form. If you know that 2 to the 4th is 16, then sure, now you can write 16 y to the 6th. But you may leave it in that form if you wish. Here we have a negative exponent. So really no need to distribute the whole thing in because it's not going to change it. It's just going to make them negative exponents. So now you have p cubed q squared. And they're both in the denominator because they both have a negative exponent. It goes into the denominator and 1 doesn't change anything. So there you go. parentheses. They're really not needed. There's nothing going on. You just group your like terms. This is not FOIL. You're not foiling here. It's just W and W. So you're going to work with W cubed and W to the 6th. Those are the two we're going to work with. And then X negative 2, X negative 1. So this is W to the 9th and X to the negative 3. So W to the 9th and X to the 3 is going to be in the denominator because it has a negative exponent. The W does not have a negative exponent, so it does not go to the denominator. We look at the 5, and the 5 has its own exponent. So when we distribute the exponent to each one of those, this becomes 5 to the negative 3rd exponent. And S to the positive 6, because negative 3 times negative 2 is positive 6. T to the negative 12. So here we have S 6 over 5 cubed T to the 12th. Here, now, if I'm going too fast with these, pause the video. Pause it before I start it. Try it on your own. Then see if your process is the same as mine. Don't sit there and copy. So go ahead. I did one just like it. Go ahead, pause the video, and give it a try. So I'm going to take the negative 3 and multiply it to each exponent. And this is 3 to the negative 3rd, and A to the negative 9, and B to the negative 15. Now notice how they all have negative exponents. So they're all going to go to the bottom. You're welcome to turn this into a 27. You don't have to. You can leave it 3 to the 3rd. Right. Go ahead, try this one. What I'd suggest is for us to first start with the x's. Notice that we have an x to the negative 1 and an x squared. So we're going to have the x squared, and that x to the negative 1 is going to come down to the bottom. Well, when you work with the y's, the y to the negative 1 is going to go to the top. So we're going to have a y squared, and we're going to have a y to the 1st. So that ultimately gives us y cubed, x cubed. Pause the video, give it a try on your own before I try it. Here we'd be working with just the 3 and the 9, and then we'd be working with just the C, then we'd be working with just the D's. Treat them as separate problems. You can't do them all at once. You do them separately. You look at them separately. So when you divide a 9 and a 3, of course you get 1/3. Here you have 3 on top and 1 on bottom. You have 3 C's on top. You have 1 C on bottom. So now you're going to be left with just 2 C's on top. So C squared, with really nothing left on bottom. So we just call it 1. And the negative is going to go to the top. So this is D to the 1st and D to the 1st. So as we clean this one up, we have C squared with D squared, because they're both on top. And then the 3 is on the bottom. Go ahead, pause it, try it on your own. Then you can come back and see if your process was correct. Here we have 4 over 24. We have r to the fourth, r to the fourth, s to the fifth, and s to the negative fifth. Well, of course, we're going to work with our constants and say 1 over 6. These are the exact same. 4 minus 4 is 0. So it's r to the 0, or they cross out completely. And here you're going to bring that to the top. So it's going to be s to the fifth and s to the fifth. So this is s to the 10th over 6. You reduce the 4 and the 24, and you work with the s's. The r's cross out completely. Two and 23, a cubed and a to the fifth, b to the negative 4 and b to the negative 2. There's nothing we can do with the 2 and the 3. If we have 3 a's on top and 5 a's on bottom, we're going to have a squared on bottom. 3 minus 5 is a negative 2. The negative implies that it goes to the bottom. These are both negative, so this is going to go to the top and this is going to come to the bottom. So b squared, b to the fourth. Then you write it as a single answer. So we have the 2, the b's, you have 2 of them on top and 4 of them on bottom, which is going to leave you with 2 left on bottom. BB, 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 2 left on bottom. 2 minus 4 is a negative 2, 2 on bottom. So the 2's on top. The 3a squared, b squared is left on bottom. Here we're watching and we're looking at what we have. It doesn't look like there's much of a reason to group them by fraction because there's no like terms, there's no z's on top and bottom, no y's on top and bottom. They're in separate fractions. So really, the separate fractions are not needed at all. You have the 4, you have the z cubed, and you have the y to the 7th. So the 8 and the 4 can be reduced, and that becomes a 2. You have 4 more z's on top than you have on bottom. 7 minus 3 is 4. You have 4 more y's on top. There's 11 y's on top. There's 7 y's on bottom. Cross them out. You're left with 4 on top. So our final answer is 2 y to the 4th z to the 4th, and everything else is crossed off on bottom. So you would be a 1 in the denominator. You don't need to write the 1. You can leave it just like that. Okay, you go ahead and try this one. Pause the video, work it out, and come back and check it out. So a couple of different things we can do. Here we notice that the y is negative, so it's going to go to the bottom. We already have a y squared, so we're going to call that y cubed now. We also have, we don't even need to write 2 fractions. We have a y squared on top, but the negative is going to tell you to put the x to the 4th on top with it. So we have a total of x to the 6th on top, because x squared and x to the 4th, you add the exponents, you get x to the 6th. We have a y squared on top and a y squared on bottom. They're going to cross each other out. So 3y cubed is left on bottom. So, multiple choice. How do you do this with multiple choice? The best case is not to try to guess your answer through it, is to do the problem and then find the answer. So, we have 2 over 6. We have x squared over x. And we have y over y to the negative 1. Well, the 2 over 6 leaves us with 1/3, so that's a possibility. They're all a possibility. The x's, you have 2 on top and 1 on bottom. XX with an x on bottom. One set crosses off, you're left with an x on top. So this probably isn't the answer. This could be, this could be, this would not. And then the y's. The y is a negative, so it's going to come to the top with it. So we get a y squared. So x, y squared with a 3 on bottom. Looks like the answer is B. Don't guess your way through it. Do the calculation. Identify the correct answer. Understand why the other ones do not work. All right. Write the expression of the figure in terms of x. So get the x by itself. So the side length is x divided by 3. So the area is the cubed root over 4 of x over 3 squared. Well, we're going to square the x. We're going to square the 3. So that's going to give us x squared root 3 over 36. I always like to put our radical last and put your values in front of the radical. Here, the volume equals pi. The radius is x. And your height is x. We are writing these equations in terms of x. That means we just need to simplify it now. We got the x in the problem, and we simplify it. Get the x in the problem, and simplify it. Here, when you're multiplying a fraction and a value, the tops multiply each other. So this is pi x cubed divided by 2. A couple different ways you could write it. That would be the same thing as 1/2 pi x cubed. That is true too. Okay, length times width times height. So the volume, the length, the width, and the height. Here you multiply the tops of the fraction. Gives you 10x squared over 3 times x. You multiply the tops of the fraction, 10x cubed over 3. You could also call that 1/3 10x cubed. Your choice. What are the zeros of the function? Alright, this is going back to some review questions. What are the zeros? Where does this cross the x-axis is what's being asked. So, there's different ways we can do it. We can either do quadratic formula. You can factor if possible. The safest route right now might be quadratic formula. But let's do a quick. We typically like factoring if factoring is going to work out. Can you multiply to be negative 36 and add to be positive 5? That's going to be a positive 9 and a negative 4. So it looks like this is factorable. So we're going to get 2x squared plus 9x minus 4x minus 12. So I'm factoring by grouping. Group our like terms together. So that leaves me with an x. 2x plus 9 is left over. Over here, okay, let me take another look at what I have, because when I factor, I have a negative, and I factor out my 4, I'm going to get x minus 3. So something's not working. I see. I did 2 times 12 is 36. 2 times 12 is 24. And that's going to be 8 and negative 3. So that kind of changes my problem up. So that's the advantage of factor by grouping. It allows you to check your work as you're going. This is 8x minus 3x. So we have 2x, leaves us with x plus 4. Bring down your sign, factor out your 3, leaves you x positive 4. Because a negative times a positive is a negative. So this is going to leave us 2x minus 3 and x plus 4. Now this whole time this is equal to 0, because we're trying to find the zeros of the function. So we're going to take 2x minus 3 and equal it to 0, and x plus 4 and equal it to 0. Add the 3, divide by 2, subtract the 4. So notice what I did. I solved the problem. There wasn't a lot of room, but I solved the problem, then I can find my answers. Here the x is the wrong 4. This one looks good. This one is the wrong sign, and here this one's the wrong sign. So C looks like the best answer. In the diagram, NP bisects angle PNQ. So this looks like a little bit of geometry class. And the measure of angle MNP is x. Write an equation that can be used to find y, which is the measure of MNQ. Well, if this is a bisector, that means they're both the same. Both the same on either side. So y is going to equal 2 times x plus x. Or, I guess that's wrong. It's 2 times x, or it's x plus x. It's not both of those put together. Okay, so the whole thing, which is your y, which is the big angle, equals 2 times the x. Now we'll factor. This is the difference of 2 squares. We know it's the difference because it's minus. We know it's the 2 squares because you can take the square root of both of those. If that is your case, then it's the square root of x squared and the square root of 9 with a plus or minus. These are conjugates of each other. If you multiply them together, there is no middle term. Negative 3 and positive 3 makes 0. So that's why that works together. This here is actually going to be a perfect square trinomial. Okay, you might not recognize that, and if you just factor it like normal, that'll be completely fine. We'll practice that on number 27. But what I'm checking out is that, can you take the square root of your first term? Can you take the square root of the last term? Is the middle term 2 times those two multiplied together? And the answer is yes. So we have 2x plus 1, it'll always be that sign, squared. So you're testing to see if it's a perfect square trinomial. And once it was, then you could take the property of A plus B quantity squared. This one, we cannot take the square root of the first term. You cannot take the square root of the last term. So this is not a perfect square trinomial. So really, if we're factoring it, this is what we have to think about. If you're not going to use guess and check, then we have to say 3 times negative 8. That gives us a negative 12. I know my signs have to be different from each other. And my larger number has to be positive because it's got to add to be a positive. So negative 1 and 24, that multiplies. Negative 2 and 12, that multiplies. Negative 3 and 8, negative 4 and 6. So there's several different ways to multiply to be negative 24. The one that gives us a positive 10 is this case. The 4 and the 6 only gives us a positive 2. So we don't want that one. So we're going to say 3x squared minus 2x plus 12x. That's the 10 in the middle. And then the negative 8. Factor by grouping. You can factor out your x. Bring down your square. Factor out your 4. 3x minus 2. So your two factors are the x and the 4. Both the x and the 4 are multiplying 3x minus 2. Last row. We look at this one and we think, ooh, difference of two squares because there's a minus. But that's not a square rootable number. That's not a square rootable number. So this is not the difference of two squares. But it is divisible by 2. So if you factor out the 2, so we factored it. Now we look at it and we see the difference of two squares. Now you can take the square root and take the square root. Now when we say 9x squared, positive 3, negative 3 is 0, negative 1. Okay, let's take a look at guess and check in this format. Alright, a guess and check. How do you do guess and check? Well, we know that FOIL says the first term times the first term's got to make this. Well, there's only one option. That's why this might be kind of a good idea to use guess and check for. There's only one way to get 2x squared. 2x times x. Now, there's two different ways to get 15. 1 and 15 and 3 and 5. I don't know which one's right. I'm guessing that it's going to be 2 times 5, which is 10, and then 3 and the x. But that gives us 10 and 3 is 15. So that didn't work. Let me try the other way. Let me put the 3 over here. That gives me 6. 6x and 5x. Ah, that's my 11. See the guess and check? You got to check your work. You got to figure out where the numbers go. We don't just guess. We actually check it. They both would be positive. Now if we FOIL it together, we can verify completely that that is the correct order. So that checked. So this is our answer. Alright. Now with this one, I kind of look at it and I go, oh, there's a 9 here. So that means this could be a perfect square. But that's not a perfect square. So that doesn't work. These are some big numbers. I don't want to do 12 times 9. There's too many factors of 12 to figure out guess and check. So, but I notice that they're all divisible by 3, so I can pull my 3 out. And then now I could do 4 times 3 to make 12. -6 and -2 to make -8. So if you like to go back to factor by grouping, because guess and check just wasn't your friend, factor the first group, factor the second group, factor this out to get a 2, 2x, always an x there, is going to leave us with another 2x minus 3. Bring down your sign. Nothing can factor out, so you have to factor out a 1. That leaves me with a 2x, -3, and a -1, and a -3 make a +3. So I have my 2x and my -1, and then my 2x and my -3. So I factor them apart. Okay? So I hope you pause the video before every question and then work through it, and then got to see me work through it also. Hope all went well.